Hello, and welcome to Let's Make a Top-Down Shooter. This video is about adding the Frosty Step Niagara System and Chilled Slow effect. And a special thanks to all my supporters. Your support is what makes this worth doing. So when we added the Chilled Slow effect previously, it was for reducing movement speed and firing rate. We tested against player character, it looks good. For the enemy character, it doesn't support either of those yet, so we'll add those. First of all, we need our default walk speed copied over to our enemy character. And we also need the on move speed multi-attribute changed function. Right click to create this. This function was just get character movement. Max walk speed is equal to our default multiplied by this data value. We're getting the red underline because we need to also include our include for the character movement component. And then in begin play, we want to record the current max walk speed and also add this delegate. So with that, I can compile and launch the editor, and I'll skip through that as usual. So with our new player power, I'm going to add another Niagara system. In this case, I'm just going to duplicate the FireBall, which should probably be called Explosion, but now we also have Chillsplosion. And for this, we're just going to change our color to a blue tint. We then need to update our Frosty Step. I'm going to add a function called Chillsplosion. This will take a location, which is a vector, and in here we're going to use very similar code to our BP FireBall in Explode. So I'm going to copy basically everything. So in here we have the location is sent in. It's going to be the Chillsplosion Niagara System. Otherwise that can stay the same. Our sphere overlap will be based on our get location parameter sent in. We don't need the owner AC to be saved because we're only going to be using it the once. I'm going to trim this a little bit. Screen moved when I let go of the click button. Messed it all up. Alright, so I don't want this loop. I don't need this owner AC. So I can drag that back over here. Instead, we're just going to use our get avatar actor to get the ability system component. And that is our source, conveniently named target. And then we switch this to GE chilled. So this function will create the Niagara system, overlap some actors, and apply chilled to anything in range. To call it, we're going to change the logic in here slightly. When our capsule trace had hit a target, we're taking this location and calling set actor location. So instead, I'm going to get rid of this. I'm just going to make this, oops, wrong one. Drag this onto our location. I could have held Alt when I released there, and it would have been a set as well. So now instead, when it hits, it's just updating the destination. We don't need this here, and we'll call it on the destination. So instead, we want this to go into here. Just drag that back over here. And then we're going to call Chillsplosion for both our starting location and the destination. And of course, end ability. And the set actor location needs to also be the avatar. So we'll go in and test that. When I hit space, you can see there's 2 Niagara systems being generated. I'll go in and find some enemies. If I jump from them, hey, stop moving, to another one, they both get chilled. Not affecting fire rate yet. Let's go ahead and change that. The enemies are just using this GA. All it's using for firing rate is it has a cooldown. So then all we need to change in this case is the cooldown. So this is the GE cooldown enemy attack. So instead of using just our scalable float magnitude of 1 time per second, or 1 second duration actually, we're going to switch this to attribute based. Set the backing attribute as firing rate. So you may guess what happens. Our default firing rate is also 1.0. The chill effect will apply a 0.5 multiplier. And what that does is you can see this person here shooting once per second. We chill them. Now they're actually shooting faster. Why is that? Because it's applying a times 0.5 multiplier to the firing rate, and firing rate is being used as the duration in this case. We actually need the inverse of firing rate. So the way we're going to do that in this video is we're going to create a new C++ class. This will be of type Gameplay Mod Magnitude Calculation, MMC for short. I'm going to name this TDS Firing Rate Duration, MMC. As usual, we'll wait for the live coding to finish. And then we'll close the editor. We don't need to save that. I don't know why it updates that when they're being used. We waited for the red bar to go away and then we reload. So in our header file, we want to include a variable and a few functions. So we're adding a constructor and we're defining a attribute capture definition variable. We're then using the calculate base magnitude, which if you go into the parent class here, you can see calculate base magnitude is a Blueprint native event. If we actually click on that, you can go to that, it will tell you it's designed to be overridden by a Blueprint, but also has a native implementation, and you basically just put underscore implementation in the name. So that's how we got to calculate base magnitude and underscore implementation. And then to implement this, we're including our TDS weapon set so we have access to that. We're using our firing rate def variable. We want to capture the attribute firing rate. We use the attribute sets utility function get attribute name attribute, in this case firing rate. The source in this case will be source, not the target, and then snapshot we're setting to false. Snapshot is just generally used where you want to take a snapshot of what the attributes are at. Well, in this case, this attribute, and if it changes between the time you capture and snapshot it and later, it's using the old value. In this case, this is happening all immediately, so I'm pretty sure snapshot doesn't even matter. We then need to add it to the relevant attributes to capture so that it can be used down here. We put in a probably familiar little bit of boilerplate to get our source and target tags into our evaluation parameters because that is required for the function where we get our captured attribute. So then we're just defining the variable, filling that variable, and then making sure that it is greater than 0 by using max, because we're using it down here to inverse the firing rate. So firing rate is how many times per second that your attack is firing. Duration for a cooldown would just be the inverse of that. And back in the editor, we will go to our cooldown enemy attack, and then we'll switch this from attribute based to custom calculation class and choose the one we just created. So now we have these enemies. I got all 4 of them. You just pay attention to one of them. It's now shooting once every 2 seconds. Thanks for watching. If you liked the video and would like to see more, you know what to do. If you would like to support this channel or just want to download the project files, you can do so through my Patreon linked below.